Hi, I'm Yang, a PhD student at Virginia Tech. We propose PrivacyGuard, a system that leverages blockchain smart contract and a trusted execution environment to enable individuals' control over the access and usage of their private data. In recent years, mass data breaches come out almost on a weekly basis, and every data breach involves leakage of sensitive information that can be used by malicious parties. Data privacy as a research topic has received a huge interest from the academia, industry, and government agencies. Traditionally, two privacy goals are commonly observed. The first is confidentiality protection on user data. User data should never be exposed without legal consent. The second goal is data access control. Only those with permission can access the sensitive data. For both goals, the solutions usually involve cryptographic methods, cybersecurity tools, and common sense, such as avoiding centralized storage of plain text data. However, to build a truly responsible data economy, these two are not enough. Avoiding data misusage is also a privacy concern. Among the recent data misuse cases, the most notorious one is the Facebook Cambridge Analytica data scandal. As many as 87 million Facebook users' profiles have been harvested without consent and used for illicit purposes. Therefore, we identify a more refined privacy goal, enforcing data owner-defined data usage policy. Data owners should have full control over how their data can be used, including who can use the data for which operation, at what condition. The usage records should be non-repudiable and can be audited by data owners. For example, if you only want your DNA record for ancestry search, you won't allow it to be used for detecting genetic disease, which perhaps can be used by your medical insurance company. This new privacy goal can eventually enable a data economy. Data owners can confidently provide data for analytics without worrying about data leakage or misuse. But so far, for now, our society can only detect data misuses and punish violators from hindsight with legal process. In this work, we present a rather technical solution called PrivacyGuard to prevent data misuses and empower individual users with full control over the access and usage of their private data. Specifically, a user in the data economy can take one of the two roles, data owner and data consumer. A data usage policy allows a data owner to specify who can use their private data and also ensure that the data are used only for the intended operation under a certain condition. The policy appears in the form of a public data contract. Data operation is a data analytics program that has been ratified. A data transaction is an invocation of the data contract and fulfills the contractual obligations. We use blockchain smart contract for encoding and enforcing data usage policy and keeping a non-repudiable usage record. We use a trusted execution environment, or TEE, for the confidential off-chain execution of data operation specified in the data contract. Individual data owners can define their own usage policies for their private data in the data contract. Data owners' data are generated by sources and collected by its individual data agent, who passes the encrypted data to the cloud storage. A data broker can be used to represent a group of data owners. Then, data consumer may browse the available data contracts and initiate a data transaction by invoking a target contract. A naive method would be encoding the operation program directly in the contract and executing it on-chain. This, however, is computation inefficient since on-chain operations are fulfilled by decentralized consensus and replicated in every blockchain node. Also, it does not protect data confidentiality. Instead, we move the data operation off-chain, executed in a trusted environment. And then we need to solve the challenge of correct execution as well as secure result commitment. First, a data transaction is invoked by data consumer. Then, an off-chain contract execution environment for the data operation is bootstrapped and remotely attested by the two sides before provisioning decryption keys. The dataset is decrypted inside the trusted environment, and the operation follows. Two-party commitment protocol enforces the atomic completion of the data transaction that guarantees the data consumer gets the result and the data owners get the payment. We have implemented a prototype of PrivacyGuard. We use Intel SGX as TEE platform and Ethereum as the blockchain smart contract platform. Our paper is accepted by ESORIX 2020 and is available from arXiv. And this work is supported by US National Science Foundation. Thanks.